Right. At the beginning, I mean, 3 months and a half ago, the situation was maybe in the meantime something changed in people's lives. What can I do? So today, I think, is the 25th. So you said you want us to start with 53?
Yeah.
And page? That's okay, page.
414.
Page 414. 416. Okay, 53, very good. So we have the integral from 0 to 1 from cosine pi t divided by 2 times dt.
What my initial thing
Evaluate the definite integral. Yes?
Sorry?
Yes?
Was to make y equal to pi t over 2.
Absolutely. So now dy equals
Pi over 2 dt.
Exactly.
So
Let me show. Good, excellent. So I
well,
need
John and Allie and what's his name here usually
So obviously I do have the dt, but I don't have the pi over 2. I'm going to put it in there, pi over 2, and then 2 over pi in front. Pi and pi will go away, it's 1, and 2 will go away, and it's 1. However, now this becomes dy. And what does this become?
so cosine.
Very good.
Cosine of yeah.
Good. So now the new integral is 2 over pi, the integral from cosine y dy. Once I moved from t to y, I can no longer copy the limits of integration. So when t is 0, how much is y? 0, right? When t is 0, y is 0. When t is 1, how much is y? We shut the door because they were laughing out there. So pi over 2. Any questions so far?
So you're converting?
So once I change the integral, from t to y, I cannot copy the limits of integration 0 to 1.
We just discussed.
Yes, you cannot do that.
To do that, what you do is place it into
I have a new function.
pi t over 2.
Yes, I have a new function. When t is 0, this is 0. When t is 1, this is pi over 2.
Okay.
So now which function prime is cosine y?
Cosine y is sine. Negative sine.
No, sine y prime is cosine y, right? From 0 to pi over 2. So now we leave 2 over pi in front. And I plug in pi over 2. So I have cosine, sine pi over 2 minus sine 0. Yes, John? Yes.
Yeah.
So what does this equal to? How much is sine pi over 2?
Like 1.
Yes, how much is sine 0?
0.
So the answer is 2 over pi. Very good. Anything else?
I did have a couple.
Please.
Here's one of them. I think it's just evaluate the integral.
That's fine.
It's the integral of 0 to 1, and in the inside is x to the e plus e to the x dx.
Like this?
Yes.
Very good.
What number is that?
37, but I don't have the page written down.
37 on the same page. Okay, very good. So I have to find the antiderivative of x to the e, which is plus 1 over e plus 1. So if you have x squared, you will say x to 2 plus 1 over 2 plus 1. Now you have e, which is another number.
That's confusing me a little bit.
I have that, but
I
I also thought,
understand the equation, but if you do it in reverse, I don't.
Right. So you have x to e plus 1 prime. You bring down e plus 1 and you subtract 1 from the power. And you get x to e. Right? This is a formula we talked about.
Yeah, I know.
Right?
I know.
I have that.
Good. Is this okay? So plus. Now remember, let me refresh your memory. E to the x prime is e to the x.
Yeah.
But what about,
Times the inner.
okay,
Which is
times
actually
x prime, which is 1. Excellent. But what about a to x prime? What did we say that was equal to? It's a to x times x prime, if you want, which is 1, times natural log a.
So I think that's where I got confused. And by the way, it's plus e to the x, not b to the x. Yeah, that's
E to the x?
Yeah.
Oh, I'm sorry. Then this discussion doesn't have
Okay.
place here. I'm sorry. If it's e to the x prime is e to the x. The antiderivative of e to the x is e to the x. Sorry about that. But that was a little bit more interesting than e to the x.
Yeah, I wouldn't
From
thought
0
of
to
that.
1. Is this okay then so far?
Yeah.
Okay, so then I plug in 1. So 1 raised to whatever is 1. So it's 1 over e plus 1. Plus, when I plug in 1, it's e. And now when I plug in 0 for x, I get 0. And when I plug in 0 for x here, I get minus 1.
How do you get minus 1? Okay.
Plug in 0.
I thought anything to do with 0 was
1.
just 1, so why is it minus 1? Oh, never mind, because you're minusing.
Yes, it's
f
f of the upper minus f of the lower. Correct. So now I don't know how the answer is presented in the book. They may want you to find the least common denominator, which is fine.
Because I got that far and I got a decimal, and when I looked at the answer, I can't remember exactly what the answer was, but it wasn't the decimal that I got. It wasn't even the decimal.
So 1 plus e squared plus e minus 1. These two go away, these two go away. So the answer is, the exact answer is e squared over e plus 1.
Okay,
I don't know what they got.
we got it.
1 over e plus 1 plus e minus 1.
That's it. 1 over e plus 1 plus e minus 1. But I was saying, in case in the book the answer is combined in the sense that it's just on one fraction, then I found the least common denominator. And the final simplified form will be e squared over e plus 1. So it's either this or 1 over e plus 1 plus e minus 1. It's up to you. They are numbers. So this or this is the same thing.
That's from page 395.
395. Thank you very much. Good. Anything else?
I do have more, but
Please.
anyone else has more?
No. We want yours.
On the same page,
Yes.
39,
Okay.
which is
I would rather you dictate it to me, but if you want me, I can open the book.
so it's the integral of 1 over the square root of 3. Oh, sorry, like the bottom and the top integral. So the bottom integral is 1 over square root of 3, and then the top integral is square root of 3.
Okay.
But yeah,
I guess
that's the
I guess I
integral.
have to look at it. So you said 39 on 395?
Yes.
39, 39, 39. Oh, I see what you mean. You're giving me the limits of
Yeah,
integration.
in limits, that's what sorry, I didn't mean to-
That's okay. 1 over the square root of 3 to the square root of 3. And this is 8 divided by 1 plus x squared dx.
I don't think it's in
No, of course not.
okay.
I just want to show that
Oh,
I got
Brand new one.
I'm brand new. The other one was completely dried out. See, are you happy now? Very good. We did this problem in class. And this is the problem that I just talked to Dan about like 10
okay.
minutes ago, but that's okay. So this is obviously 8, the integral from 1 over the square root of 3 to the square root of 3 from 1 over 1 plus x squared dx.
Okay, so that's what I didn't do. I didn't move 8 out.
So now, which function prime is 1 over 1 plus x? Thank you. So this is 8 arc tangent x from 1 over the square root of 3 to the square root of 3. So now this is 8 arctangent of the square root of 3 minus arctangent of 1 over the square root of 3. And last time we calculated, yes, this is indeed pi over 3, and this is indeed pi over 6.
Okay, I do.
I would have not remembered, but we just talked about it. Probably, I would have not, I don't know.
So I think this is the one that I tried doing last night just to practice, and I just forgot that we did it.
Yeah, so pi over 3 minus pi over 6. This is 60 minus 30, so it's pi over 6. So it's 8 times pi over 6, and I will only simplify by 2. So the answer is 4 pi over 3.
Okay.
Next question. Anything else?
I don't think this is the same page, but the
It doesn't-
question is, it's a indefinite integral, so it's the integral of 1 plus tangent squared x dx.
Like this?
Yeah.
Very good. Which function prime is 1?
X.
Plus, which function prime is tangent squared?
Negative secant squared? No.
So I cannot determine a function whose derivative is tangent squared. So now there is something else I have to think about. Meaning, there are 3 identities. Basically, one is the basic identity, and from that basic identity, 2 identities result. Here it is. Here they are. So I'm going to leave some room because I'm going to come back, but I have to explain one thing. So what about sine squared x plus cosine squared x? How much is this?
Tangent squared x intended.
Sine squared.
1.
Thank you. And let's suppose now I divide both sides by sine squared. What do I get? Sine squared divided by sine squared
1.
plus cosine squared divided by sine
1
squared,
over tangent.
which is cotangent.
Cotangent.
And 1 divided by sine is?
Divided by sine is cosecant.
Thank you. Perfect. Now imagine that you are dividing the same equation, but this time both sides by cosine squared. Sine squared over cosine squared is?
Sine squared over cosine is tangent.
Cosine squared over cosine squared is?
1
And 1 over cosine squared is?
secant.
Now look at our integral.
I totally forgot that I piece of paper from my last class and it's like all the identities right here. I forgot about it.
Okay, so look at the integral and the function we have to find the integral from, and draw a conclusion.
So we need to find the antiderivative of secant squared x.
Exactly. Which is? Which function prime is secant squared?
Is tangent. So that's the answer, tangent x plus
That's it.
tangent plus c.
Yes.
Okay. So, yeah. Memorize it again.
We don't have a function whose derivative is tangent squared. Next question. Anything else? If not, I will choose.
I did have. The one that confused me was it's a definite integral, so
Yes.
it's the integral from 1 to 2. And it's v to the third plus 3v to the sixth
V to the third plus 3v to the sixth.
over v to the fourth dv.
Perfect. In this case, I split the integral. V to the third over v to the fourth. 1 over v plus 3v to the sixth over v to the fourth is 3v squared dv. Always remember, I have to check whether this function, whatever it is, on a definite interval, in a definite integral, I have to make sure that this function is defined here. Yes, it is, because it's not defined at 0 only. So now, which function prime is 1 over v? Natural log of the absolute value, careful, you have to write absolute value, plus 3v to the third over 3, and everything, of course, from 1 to 2. Is that okay so far?
Oh, you said v squared, that right there.
6 over 4. 6 minus 4
Oh.
is squared.
Oh,
And the other one you just took, you divided v to the fourth with v to the third, which is
Exactly. 1 over v, which is the natural log.
well, so where'd you get v to the third power over 3?
I integrated 3v squared. 3v to
Oh,
the third
you-
over 3.
oh.
Right? So then I plug in 2. Natural log 2, I can drop now the absolute value. There is no need for the absolute value on 2. And then plus 8 minus, when I plug in 1, I get 0, and minus 1. So the simplified form is natural log, and the exact answer is plus 7. Is this okay?
Yes.
Perfect. Questions on this?
And then I think the only other one there written down that I had trouble with.
Yes, I'm ready.
Actually, no, never mind. I got
Very good questions. Very good
I
questions.
got an answer. Just trying to see if there's anything I can mark down that I had trouble with. Oh, this is kind of like 4.9, but it gave me trouble.
Doesn't matter.
So it was f of x equals, I think it's just f of x equals square root of 2. And I'll just have, maybe this is just before I understood it completely. But that's it. I'm just trying to figure out what I had trouble with.
So we are given a function that is the square root of 2.
I ended up getting the square root of 2x plus c. Like as the answer.
Can you tell me which problem it is so I can...
All I know is 348. Number 9 on 348. Alright, these are just questions I had trouble with when we first started this section.
That's okay,
So I
that's
just
okay.
guess I'm back
Number
to it.
9. No problem. Number 9. Yes, you're right. Number 9 is indeed the f of x equals the square root of 2. Find the most general antiderivative of the function. Very good. So since I'm given f of x, what is the notation that I have to use?
Capital F of X.
Thank you. Equals the square root of 2 times x plus the constant c. When you differentiate this, you get the square root of 2.
Is the x inside the square root or outside?
Very good question. It cannot be inside the square root because look, if I write this, when I differentiate it, I get 1 over 2, the square root of 2x times 2. And I don't get this as the answer.
Okay.
Clear?
Yes.
Perfect.
The x is
I
on
was wondering,
the square root
So it's the square root of 2
times x.
multiplied by x. In order to be safe, we normally don't write anything behind following a square root. So it's better to write it like this. And then there is no ambiguity. Eric?
I was wondering, if this, might go to test, can we do another distance problem?
Of course. That's
Okay.
that's on the agenda for tonight, of course. And much more. But I wanted to answer your questions first. Anything else that you... Yes?
Was that in this chapter? I thought that was in last chapter that we first did that.
The distance. It was a different story then.
Was
It was a different story, yes. A different situation with the particle moving in the positive direction and a negative direction. Yeah, it was a different, similar though, similar. Okay, can I start the review now or you have something else for me?
I have one more.
Please.
Just one more. Sorry. guys.
No, let me
No,
say,
it's
let me,
Go ahead, man.
let me,
Number 11 on 348.
this is the only way.
Okay.
So you said number 11,
348.
11 on 348. 348. 348, number 11. Okay. And we have f of x equals 3 the square root of x minus 2 the cube root of x. And I'm asked to find the antiderivative of this. Since the notation is lowercase f, I have to use the uppercase f. I will not be able to find the antiderivative in this stage, in this format.
You have to,
Yes,
put x to the half.
very good. Minus 2 x to
1/3.
excellent. So now f of x will be, the antiderivative will be, since I don't have room here, I'm going to continue here, is 3x to 1/2 plus 1 over 1/2 plus 1 minus 2x to 1/3 plus 1 over 1/3 plus 1 plus a constant c. And now I have to perform these operations. 1/2 plus 1 is 3/2. So this is 3 over 1 times 2 over 3 multiplied by x to 3/2 minus 2. This is 4 over 3 over 1 times 3 over 4 times x to 4/3 plus a constant c. Is this clear so far? I didn't perform the operations before you saw them, before we looked at them. So 3 and 3, 2 and 2. So then the final simplified form is 2x to 3/2 minus 3/2 x to 4/3 plus a constant c. Any questions? Any questions? Okay. So I would like to look at, since we looked at similar problems that I wanted to go over, I would like to look at on page 353. I would like to look at problem 71. And we have the second derivative of x, which is 1 minus 6x plus 48x squared. And we are told that f of 0 is 1 and f prime of 0 is 2. That's a problem that I want to work on.
So
And then-
the first thing you want to write is integrate f double prime x, right?
Correct. So first I have to find, so I'm asked to find f of x. So our question is this.
I'm sorry, I was
That's okay. So then we have to find what first?
We just find
the first derivative of
Yes, good. So can anyone give us the first derivative?
that x minus, what is it? 6x squared 2. Plus c1, and then you can place in f of 0.
So I will simplify
Plus
as much as I can. So then I have a 6x minus 3x squared plus 16x cubed plus c1.
And then you can find out c1, right?
Now I can find out c1, yes.
0 is
So the
2x,
left hand side is
and
2
2.
and the right hand side is 0, 0, 0, c1.
c1 is 2.
Very good. So from here I know that f prime of x is x minus 3x squared plus 16x to the third and plus 2. So I finished with the first derivative.
Now you gotta do the.
Now I'm ready to move
integrate.
to find the function. Okay, so then I have f of
Do you have
x.
to write a capital F when you do that?
No, because you are given the second derivative in this form.
Because you're going the other way, right?
You are finding antiderivative, but you cannot, once you are given lowercase f double prime, you have to stick with f. You have no
Okay.
choice.
Okay.
So then this is x squared over 2 minus 3x cubed over 3 plus 16x to the 4 over 4 plus 2x plus c2. And I will simplify. X squared over 2 minus x cubed plus 4x to the 4th plus 2x plus c2. And now I will use this information to find c2. So 0, 0, 0, 0. So then c2 must equal 1. Very good. Excellent. So then f of x equals x squared over 2 minus x cubed plus 4x squared plus 2x and plus 1. And this is the only function whose second derivative is 1 minus 6x plus 48x squared and complies with these two conditions. Any questions here? Is this okay? Okay, next one I would like to look at problem 74 on 354, which gives us a of t, which is sine t plus 3 cosine t, and we are told that s of 0 is 0 and v of 0 is 2. Let's work on this for 1 minute.
So wait, what is,
So A of t.
We are asked to find the position of the particle, the position function.
So AT is sort of like S double prime, right?
Yes, exactly. On paper, 1 minute. And then we'll start reviewing chapter 5.
This is chapter 5.
No, this is 4.9. Still,
Oh, it's okay.
yes, still.
Never mind.
okay, and then velocity is the first derivative, right?
Correct.
Everything working?
No, I'm just putting the attendance in.
Oh.
I have to put it in every class. But yes, the video is working, yes.
I get paranoid now.
Me too, trust me. I do too.
That's my basis of study.
I hope that it helps at least one student. Do we have the velocity?
Yeah.
Can anyone dictate it?
Like, you want like the final after I count c?
No, no, just before.
It's gonna be negative cosine t plus 3 sine t plus c. And then we
Let's call it C1.
c1.
And I know that 2 equals negative cosine 0 plus 3 sine 0 plus C1.
Negative cosine 0 is negative 1,
Yes, so this is negative 1 and this is,
0.
yes, Dan?
So I've been confused about the sign change on that.
Yes, because when you differentiate cosine, you get negative sign. That's why you have to have a minus here, so when you differentiate this, you get positive sign.
Okay,
Because cosine prime is negative sign. And if you don't have a negative here, then this will be negative and you're changing the problem.
okay, so the,
So the negative cosine t prime will be positive sine t.
okay,
Simple cosine will be negative sign, and that's not what we have.
yeah, I didn't understand.
Better?
And
Perfect.
sine it's just sine is cosine, right? Sine prime is cosine.
Yes. So then this is negative 1, so when I move it to the other side is 3. So C1 is 3. Do we all agree? So then the velocity function is definitely negative cosine t plus 3 sine t plus 3. Okay, let's finish it up and work on the distance. And after this, I will tell you that I won my bet.
What happened?
After we finish and we find the distance, or s of t, I'll tell you how I won my bet.
How you won your bet?
Yes,
Oh, you went to the casino to play some poker.
I never
Dice
set
polo?
foot. I never set foot in this casino, and I don't intend to. It doesn't mean anything to me. No.
My brother used to be really good at poker. He says there's a big element of skill in there. Everything else though is statistically
Impossible.
it's yeah.
Yes. The distance formula, please.
Negative sine t
Yes, negative sine t
minus 3 cosine t
minus 3 cosine t.
plus 3t
Yes,
plus c like 2.
very good. Very good. Do we agree with this? Negative sine t prime is negative cosine t. Negative 3 cosine t prime is positive 3 sine t. 3t prime is t. C2 prime is 0. And I have that s of 0 is 0. 0 minus sine 0 minus 3 cosine 0 plus C2. How much is sine 0? 0. Sine is measured on the y-axis. Sine is measured on the y-axis. And this point has the y-coordinate 0. If you look at your chart.
So,
Sine is not the first coordinate. Sine is the second coordinate.
yeah, I'm confused about that. I've been having trouble trying to figure out which one that is this whole time.
You mean sine 0?
Yeah, negative sine 0.
So in your chart is right here. And the coordinates of this point are 1, 0. This is your cosine and this is your sine. So that's why sine 0 is 0. The y-coordinate of this point.
I just always remember sine 0 is 0, cosine is 1.
So this is 0 and this is 1. So this is negative 3 and 0. So when I move negative 3 to the other side, it appears that C2 is also 3. Do we agree with that? So then the function that represents the distance, s of t, is negative sine t minus 3 cosine t plus 3t and plus 3. And it's the only function that has the acceleration that is given in the problem and fulfills the two conditions given in the problem. There is no other function that does that. Any questions? Any questions? Okay, on page 417, I want to practice or review chapter 5, page 417. And I would like to start with 43. I want to work on all problems 43 through 48.
Is 40, I mean, is 417 the review for all chapter
Yes, yes, yes. I would like to start with this and then we'll go back to other integrals. And I did not forget a distance situation. We'll find one in a minute, okay? Eric wanted to see another total distance situation, which we're going to do in a minute. Okay, so let's start with 43. F of x equals the integral from 0 to x from t squared over 1 plus t cubed dt. We are asked to find the derivative of the function. For all these problems,
Okay, is this what we said we did when we were tying up loose ends?
no, it's what we did last time, but I want to practice because we only did a couple.
This is 5.5.
It's still, no, it's 5 point, when we went back at the end, 5.3.
Okay.
Remember after
This is the
last
fundamental
class?
theorem of calculus part 1. Fundamental theorem of calculus part 1.
Oh,
In
I
which-
remember trying to do this.
In which the part 1 says only one thing. The differentiation and integration are
Continuous. Oh no, or I have this first.
inverse operations, right? So in this example, I'm given a function that is in the form of an integral. I'm not asked to determine any of this, where I'm only asked to find the derivative. So I'm given a function in the form of an integral. What do I have to do to both sides to find the derivative of this function? One more time. I want to find the derivative of this function. What do I have to do to both sides?
Find the derivative of both sides.
Differentiate. Differentiate. That's all I want you to say. So I'm differentiating the left-hand side. I'm differentiating the right-hand side. So the left-hand side is f prime of x. Now carefully tell me what to write on the right-hand side.
X squared,
Very good. Hold on for everyone to see. X squared over,
1 plus x cubed.
yes. And I should write
T.
multiplied by, no.
No.
This goes away with this at the same time. These two go away at the same time. And I should write multiplied by x prime. But since x prime is,
1.
there is no need. And this is the final answer. And this proves that when I differentiate an integral, I get the function.
So that's all that.
That's all it's required. Next one. F of x is the integral from x to 1 from the square root of t plus sine t dt. I have a problem here. What is the problem that I'm encountering? Compare with the previous one and say, oh, I see the problem.
Because the square root of it.
Nope. This is a function.
That's a-
I don't
It
even,
starts at the x.
exactly.
Or it should start at 1 and
See,
go to the x.
this must be a number. The bottom limit of integration must be a number. I don't care which number. It must be a number. This is not the case here. How do I reverse the order of the limits, and what happens if I do that? Or when I do that? This is one of the properties of the integral. When I reverse the order of the limits of integration, what happens? I have no choice. I have to reverse them. So what happens when I do that?
Is it 1 over the square root of t?
So one of the properties that we discussed, the integral from a to b from f of x dx, is the integral from negative from b to a from f of x dx. So I had to proceed accordingly, and now I'm ready to differentiate. Remember, we cannot do anything here other than differentiate both sides. So now I differentiate the left-hand side, and I differentiate the right-hand side, and I get f prime. So f prime of x. Can anyone dictate?
The square root of x plus sine x? Or negative
Yes?
square root of x plus sine x.
That's it. This is it. Final. Perfect.
Why? Just because 1.
It doesn't matter. What I have here, it does not matter. Any number, but it must be a number. It cannot be a function. Ready? 45. G of x. The integral from 0 to x. By the way, I should have multiplied by x prime. But what is x prime?
1.
Very good. So the integral from 0 to x to the 4th from cosine t squared dt. Is this function in the form of an integral ready for differentiation? Yes, as long as the bottom limit is a number, whatever number, it doesn't matter, and the top is x or a function. But if it's a function, I have to remember something very important. Here it's a function, but it's plain x. Even x is a function, but it's just plain x. But this is not plain x. So when I differentiate both sides, what will I write? G prime of x equals?
Cosine x to the 8th.
Very good.
4x.
That's it. I'm going to put it in front not to be confused with whatever. So G prime of x is 4x to the 3rd times cosine x to the 8th. Excellent.
So all you did was multiply the
Yes,
x
I have to
4
use-
times 2.
I have to use the chain rule because I'm putting in a function that I differentiate. I'm putting in a function, another function. so I have to differentiate. Okay, next one. G of x. The integral from 1 to sine x, 1 minus t squared over 1 plus t to the 4th dt. Is this ready for differentiation? I have a number and I have a function. It's not plain x, so I have to be careful. So I differentiate the left and I differentiate the right. What now? G prime?
1 minus sine squared x over 1 plus sine 4x.
Times, what is it, cosine of x?
And I forgot to tell you about my bet.
What was your bet?
Last week, Eric said, I don't get it. I don't get it. And I said to him, wait till Tuesday.
Oh, yeah.
The moment he came in through the door today, he said, I got it all.
No, not all.
Okay, I got it.
understood
I got it
understood
99%.
all of
What was the bet?
principle of
I made a bet with
the,
myself. I made a bet
Like,
with,
you got to bet something. Like
Yes,
you
I-
won. So what
Yes.
do you get?
I'll find something to win. I made a bet with myself. And I won. Good, okay. Try to be funny. Careful with the next one. Okay? Y is a function given in the form of an integral like this.
Are
And
we still doing the same thing? No.
yes, we are still this one and one more. And then we'll go to your distance thing. And I look at this and I say, oops, there is no number. I can't use the procedure that I've been using before because this is a function and this is a function. And this must be a number. But I remember a very important property of the definite integral, which said the integral from a to b from f of x dx. Say it again.
Trying to find where these properties.
Okay, so the integral from a to b from f of x dx is the integral from a to c from f of x dx plus the integral from c to b from f of x dx. Do we agree with this? So the interval, assuming the function is continuous on the interval a comma b, I can split the integral into two parts. I can say, nobody's listening. Are you paying attention? Okay,
Trying
so
to find where I wrote down that
those.
property.
Okay, so if I have here from 1 to 10, 1 to 10, I can say from 1 to 6 plus from 6 to 10. Is that true?
You said that one more time.
1 to 10, 1 to 6, 6 to 10.
What makes you choose 6 though?
Doesn't matter.
Any number between 1 and 10?
Any number. Any number.
1 to 10.
I also, if I say that this is 1 and this is 10, I will say this is 1 and this is a number. And I won't even tell you which number because I don't care.
So
On a test, can we just denote it as number time? Or do you just want to say-
Anything you want.
Alright.
So this is what I'm going to do with this. Meaning, I'm going to rearrange the integral and say the square root of x to a number that you choose, e to t over t dt, plus mandatory to start at the same number. If this is 15, then you have to write 15 here. So maybe it's better to write a number. Okay, you can write anything you want. 10, 100, 1500, whatever you want.
So if it's like this, like square root of x and x, there's like, we can literally choose any number we want. It doesn't have to be in between anything, because we're just
Well,
getting square root of x.
since this is a positive number, I would say any number you want.
But as long as it's any positive number. Right.
But
I don't
X-
understand how
but
you
it-
split that up though.
Okay, if the integral is from 1 to 10,
Okay.
I can split it from 1 to whatever you want between 1 and 10, and I continue from the same point to 10. I can use 6. 1 to 6, 6 to 10. I can use 8. 1 to 8, 8 to 10. In the same way I split this one. From the square root of x to a number, plus from that particular number to x. I have one more step. This is okay, but this is not okay because it doesn't have the number as the lower limit. What do I do with it?
Put a minus sign.
Right. And now this is ready for integration. I'm sorry, I meant to write to say for differentiation.
So how come this one only has 2 and the other one has like 3, like A to B, A to C, and then...
Yeah, it has 2. I split it.
Oh, never mind, yeah.
Yeah, I split it somewhere.
So you
So
have,
now-
you have to put a negative in front of it still though, right?
Because it does not have a number at the bottom. The lower limit must be a number. Let me remind you the fundamental theorem of calculus. Let's write it one more time. So g of x is the integral from a to x from f of t dt. This is the fundamental theorem of calculus part 1. Fundamental theorem of calculus part 1. So a function given in the form of an integral. And this only enables us to see that differentiation and integration are inverse operations. And now to illustrate that, I will differentiate. I did not finish this problem. I'm just jumping to just show you or remind you about the fundamental theorem of calculus part 1. The left-hand side is g prime, and the right-hand side is nothing else but f prime of x, which is nothing else but g prime of x. Not prime, I'm sorry. I don't know why I wrote prime. Of course not. Differentiation will eliminate the integral. So g prime of x is f of x. And I didn't need to write it twice. Okay, so then we're coming back here. I'm just going to copy what we have. We have y equals negative from this number to the square root of x e to t over t dt plus from the same number to x e to t over t dt. And now we are ready to differentiate. Let's differentiate. I differentiate the left-hand side and I differentiate the right-hand side. Ready? So
E to the square root
So
of
this
x
prime equals
over
this prime. So y prime equals, yes, negative in front,
negative 5
e to the square root of x over
square root of x
times
times 1.
over,
1 over 2 square root of x.
very good, plus,
Hang on.
Is it
it's a function, it's e to the square root, it's not plain x. So plus e to x over x.
I'm sorry.
That's okay. So I will simplify by multiplying these two. So this is final now. E to the square root of x over 2x plus e to x over x, and this is it. I would like you to work on one of them. 1 minute. The last one here, 48. On 417. Here it is. Y equals the integral from 2x to 3x plus 1 from sine t to the 4th dt. Now I'm looking for a distance situation.
This is the distance one you're
No,
is this the same thing we just did?
same thing.
Okay.
Please find the derivative of this. No, now I'm looking for a problem that Eric wanted to see, which was